Okay, let's look at double angle formulae. Double angle formulae basically like sine alpha plus beta equal sine alpha cos beta plus cos alpha sine beta. And in the UK formula booklets for exams, it's really lame. They've got one for cos alpha plus beta, and they even have it for sine alpha minus beta and cos alpha minus beta, and then they have one for sine 2 alpha, even though that's just putting beta equals alpha. So they basically repeat everything about 8 times, like they've got 8 different formulae, whereas you only need 2. I'll show you the cos one as well. That's cos alpha cos beta minus sine alpha sine beta. Now the way to show this is true, you can do both at the same time. It's really neat. Again, notice almost everything is coming from the unit circle here. So we start with a unit circle and give myself an x-axis, even though I don't really need it. Okay, so that's going to be my alpha, and that's going to be my beta. Try and make them not look the same. Beta. Okay, so the trick is going to be to consider them as vectors and resolve this vector in terms of this one and its 90-degree. How can I best do this? There we go. This central section of the rule is quite useful for getting 90-degree angles. Okay. So if I call that vector u and that one v, the question is, can I write this vector, what should we call this now? We've called these u and v, r for resultant, I suppose. Can we write r in terms of u and v? Obviously we can. So what's this component here? That's just cos beta. So we're going cos beta in the u direction, and we're going sine beta in the v direction. Yeah? Could okay, so r equals cos beta in the u direction in the u direction, that's a unit vector, and the distance is cos beta, so r is cos beta u plus sine beta So now it just remains to write what are u and v. Well, do the same trick here. u is just in the x direction it's cos, in the y direction it's sine cos alpha sine alpha. Okay, and v, instead of going along and then up, we're now going up and then back. Do you see? Bom bom, bom bom. It's like a swastika if you do it 4 times. So v is equal to the amount we were going in the x direction, we're now going in the y direction, and the amount we were going in the y direction, we're now going in the minus x direction. Okay, so therefore r equals cos beta cos alpha sine alpha plus sine beta minus sine alpha cos alpha, which is cos beta cos alpha plus sine beta sine alpha cos beta sine alpha plus sine beta cos alpha. But we could have just gone directly using this combined angle. We could have just r is also equal to cos alpha plus beta sine alpha plus beta. So these two things are equal, so therefore the x components are equal. So cos alpha plus beta has to be cos beta cos alpha plus sine beta sine alpha. I've got a minus sign somewhere. Wrong, that should be minus. Ah. And sine alpha plus beta is cos beta sine alpha plus sine beta cos alpha. And I suppose I'd rewrite these as a final step with the alpha before the beta, and then I have these formulae. So again, as I said, it's really idiotic in the formula books that they then give you separate formulae for sine alpha minus beta cos alpha minus beta. I mean, it's a trivial thing to throw a minus sign in. Sine alpha minus beta, you replace beta with minus beta. So cos of minus beta, that's just the same as cos beta, because your cosine wave is symmetric around 0. Yeah? Cos of minus something is the same as cos of plus something, because it's symmetric. Sine is anti-symmetric, so when you have to do replacing beta with minus beta, sine beta becomes minus sine beta. So you end up with sine alpha cos beta minus cos alpha sine beta. Yeah? And then you've got the formula booklet gives you another pair of formulae for sine of 2 alpha and cos of 2 alpha. Sine 2 alpha. That's just alpha plus alpha. So sine alpha cos alpha plus cos alpha sine alpha equals 2 sine alpha cos alpha. And cos of alpha plus alpha, cos squared alpha minus sine squared alpha. Yeah, but as far as I'm concerned, none of these there shouldn't even be a formula booklet, because these things should be taught from a point of understanding rather than as something to remember. If it's something to remember, people will just resent it. No one wants to fill their head full of this stuff. But for a minority of people, a substantial minority, it's fun to figure out where these things come from, and it will stick without any effort, because once you see where it comes from, then how can you forget? Okay, that's all for this one.